All right, in this video, we're going to be looking at the integral of 2x plus 1 divided by x squared plus 2x plus 5. Okay, so our strategy, first of all, is going to look at the bottom here, this trinomial. We're going to complete the square on it. So recall when you complete the square, x squared plus 2x plus 5, you take that middle term, that 2, divide it by 2 and square it. So that becomes 1 squared, which is 1. Okay, so to complete this square, you need x squared plus 2x plus 1. That's completed the square right there. But then you have 4 more, so let's put the plus 4 out here. This will factor into x plus 1 squared plus 4. Okay, so that's the substitution we'll do on bottom. Okay, so we get the integral of 2x plus 1 divided by x plus 1 squared plus 4 dx. Okay. Okay, so now we're going to do a substitution. Let's say we have u is equal to the x plus 1 here. So u is equal to x plus 1. Okay. If you move that 1 over, you could also say that x is equal to u minus 1, which is going to come in handy. Okay, and if you take du, take the derivative of both sides, the derivative of this is just 1, so we'll say it's dx. Okay, so I'm going to substitute in. Everywhere I see an x, I'm going to put this. Everywhere I see a x plus 1, I'm going to put a u. Okay, so here's the x, so 2 times u minus 1 plus 1 divided by x plus 1 is u, so u squared, didn't need the parentheses, but whatever, plus 4 du. Okay, let's distribute this 2 out, so that will be the integral of 2u, and then minus 2, right, but plus 1, so minus 2 plus 1 is minus 1. And on bottom, we just have u squared plus 4 du. Okay, so what I'm going to do now is split this up into 2 separate problems. Okay, so I'm going to split this fraction up. The first one's going to have this as a numerator, 2u. Second fraction is going to have a minus 1 as the numerator. So integral number 1 that we're going to do is going to be 2u divided by u squared plus 4. Okay, and then minus, the minus comes from this minus 1 right here, the integral of 1 over u squared plus 4. Okay, this will be integral number 2. Okay, so looking at integral number 1, okay, so what I'm going to do there is another quick substitution. I'm going to say that t is equal to u squared plus 4. So that would mean that dt, oops, I forgot my du on both of these. Bad about that. Okay, and dt is equal to 2u du. Okay, and if we solve that for du, it would be du is equal to dt over 2u. Okay, so I'm going to keep working on this integral here. So I get the integral of 2u, it's on top. The bottom is going to become just a t. Okay, and then the du is this, so dt over 2u. Notice that the 2u's are going to cancel out. So you get 1 over t dt, okay, which is ln, the absolute value of t, and plus c, but we'll put the plus c at the end of the problem. Okay, so if you backtrack and put in, resubstitute back, okay, the t is equal to u squared plus 4, so this is equal to ln of u squared plus 4. And at that point, you can drop the absolute value because this is always going to be positive. And if we go back one more time and figure out what u is at the very beginning of the problem, u is equal to x plus 1. Okay, so this is equal to ln of x plus 1 squared and then plus 4. Okay, and if you clean that up, square this all out and such, you'll get ln of x squared plus 2x plus 5. And that takes care of the first integral. Okay, now we'll take a look at the second integral. That's this one here. Okay, so this one is going to be a trig substitution. So we're going to say that u is equal to 2 tangent, actually, 2 tangent theta. Okay, so keep in mind that u squared is equal to 4 tangent squared theta. And if I wanted to take du, derivative of this one right here, okay, that's going to be equal to 2 secant squared theta d theta. Okay, so that's all I need there. So I'll do this substitution. 1 over, and the u squared is 4 tangent theta. So 4 tangent squared theta plus 4. I don't need to square it because I already did it here, right? The u squared was already squared here. Okay, and then the du is equal to 2 secant squared theta d theta. Okay. Also, by the way, guys, you can look this up in a formula sheet. It is a pretty standard integral, but I'm showing you anyways. You can fast forward to the end if you don't like it. All right, so that's going to be the integral. I'm going to factor out this 4, and I'm going to put the 2 on top, the 2 secant squared. 2 secant squared theta goes there. I'm going to factor out the 4, which would leave tangent squared theta plus 1 d theta. Okay. Notice that the 2 and the 4 are going to reduce. I'm going to exchange this right here with a secant squared theta. That's a trig identity. Okay. So that's equal to, and let's keep the negative attached to it. Okay. That's going to be 1/2 times the integral of 2 secant squared theta over, oh, I didn't need the 2. Why did I do that? No 2, just secant. 1/2's already been taken care of. So secant squared theta over secant squared theta, because we already took care of this fraction right here. Okay, so those will cancel out, and you'll just get negative 1/2 times the integral of d theta. So that is negative 1/2 of theta. Okay, now just like the last one, I need to backtrack and resubstitute. So what was our theta at the beginning of the problem? Or not at the beginning of the problem, but up here. Okay, so we would have to, in order to figure out what theta is, we use this. You divide by 2, so you get u over 2 equals tangent theta. And if you take inverse tangent, u over 2, that's equal to theta. So that's what we're going to substitute in for theta. Okay, so this is going to be equal to negative 1/2. Okay, and that will be tangent inverse of u over 2. Okay, and we'll put the plus c at the end. I still need to do one more substitution because I started with x. So what was u? If we go back to the beginning of the problem, u was x plus 1. Okay, so this is equal to negative 1/2 tangent inverse of x plus 1 over 2. Okay, now I can put those two things together and get my final answer, and I'll put a plus c at the end. So final answer is this, ln of x squared plus 2x plus 5. Okay, and we know that's always going to be positive for multiple reasons here. This is always positive, this is always positive, so this is always positive. Okay, and then minus 1/2 tangent inverse of x plus 1 over 2 plus c. And that will do it.